Hello, folks. Welcome to the Solar Fit Renewable Energy Show. This is Bill Gallagher. Mighty glad you joined us today. Another beautiful, beautiful day in Flagler County. That's where we're located. And if you're tuning in from overseas, you ought to be here, folks. It's just awesome. And we're here with our good friends from Embry-Riddle Aeronautical University, Mr. Jared Nordman and Tom Gorda. Hello, guys. Welcome.
Hey, Bill. It's great to be here.
Hi, how you doing?
It's great to have you here. Hey, before we start, I mean, you know, we love to have our friends from Embry-Riddle on here. That's kind of our school, and we talk about it all the time and stuff. And we'd like to hear a little bit about your background. Jared, why don't you start first? Where are you from, and tell us how you made it to Embry-Riddle?
Well, originally I was from San Antonio, Texas, and going through high school and figuring out what I wanted to do, I met a good professor of mine who encouraged me to be an engineer. So I started looking for top universities in the country, and Embry-Riddle stood out quite a bit to me. And so I ended up coming down here. I tried out for the soccer team, made the soccer team, which was a wonderful experience for me. And then I decided to further my engineering career by joining EcoCAR last year. So I'm relatively new to the team, but it's been an amazing opportunity to work with them and to learn from them and to get my future on track with EcoCAR.
Well, that's fantastic. You still playing soccer?
No, I'm actually, I finished my third year last year and then joined EcoCAR and focused a lot more of my attention on that.
Well, it gets you slim and trim, doesn't it?
Yes, it does.
Embry-Riddle Athletics is, boy, I tell you what an awesome. We've had a lot of the folks on here talking about it, and it's just inspiring. It's good for discipline and training, and it definitely keeps you healthy.
Absolutely.
Tom, what's your background?
So I come from New Jersey, originally a student who studied aerospace engineering and changed my major when I joined EcoCAR to mechanical engineering. I joined EcoCAR my freshman year of college, and there I basically learned how to use General Motors tools in designing vehicles and have furthered my knowledge. I'm now the engineering manager for the team, so I oversee all technical data and technical operations of the car.
Well, folks, if you haven't had a chance to see EcoCAR, you need to really Google just EcoCAR, ERAU, EcoCAR, and you'll see a website that's pretty darn cool. And I'll tell you, that car is amazing. The color scheme, it looks like it's doing 200 when it's sitting there.
Mm-hmm. Yeah, that's our 2013 Chevy Malibu. We converted to a diesel series hybrid. We actually finished that car last year, came in 5th place, and so diesel series hybrid means that we have an electric motor on the front wheels that propels the car. And we have a turbo diesel from General Motors over in Italy, and that charges our batteries.
Very good. And the word eco obviously comes from the environment, ecology, clean emissions, right?
Mm-hmm. We also threw in a nice little touch. We added Eco Super Sport and kind of branded our vehicle as an ESS 2013 Chevy Malibu, which was a little bit of a personal brand for the car, which is a nice touch for us.
Well, before we get into the details of the car, because it is fascinating how this works, let's talk a little bit about the competition. There's a variety of schools entered in it, correct?
Yes.
Yeah, that's correct. So EcoCAR 3 is the current generation we're in. We started that this past school year, and the schools that are involved would be like Penn State, Ohio State, Virginia Tech, Georgia Tech, and Embry-Riddle. And there's actually 2 schools from Canada, University of Waterloo and McMaster University. And basically, all of us have the same goal where we have to design a fuel-efficient vehicle that reduces emissions as well as maintains consumer acceptability.
So does everybody start out with the same package?
Yeah, everybody gets the same vehicle platform, and I'm happy to announce that the 2016 Chevrolet Camaro is the vehicle we are redesigning.
No kidding. So everyone gets identical cars. You're starting out with a clean slate, and what they're looking for are people with the aptitude to turn this into a winning project, correct?
That's correct.
Are you pretty confident?
Oh, yeah, we're very confident. So this year we've actually had some pretty impressive scores, scoring in the 98th percentile in some of our reports compared to the other teams. And our vehicle platform is looking very strong. We're looking at a vehicle that could do about 53 miles per gallon and a 0 to 60 in 4.9 seconds.
Holy moly. 4.9 seconds. That's like a Porsche.
Yeah, it's pretty quick.
It's going to be faster than the stock, so.
Oh, my goodness.
It's impressive stuff.
And that's all out of a 4-cylinder engine.
Okay, now there's got to be some tricks. You don't tell any tricks on here, guys. We don't want your competition to hear all that. That's all secret stuff, right? Okay, so how many teams total are there?
16.
There's how many?
16.
Wow, that's a lot.
Yeah, there's a lot of schools.
We're actually the smallest school that's competing in the competition.
Really?
Mm-hmm.
Well, it's already preordained that you're going to win, so the guys are they're probably taking the cars home on the weekend now, right?
Yeah.
16. Wow, that's a lot. So they have 16 identical cars. They give them to the schools, and is it all a student-run project? I know you've got advisors and stuff, but the students are pretty much spearheading that, aren't they?
So yes, the main core of each team consists of student leaders. So you have the engineering manager, project manager, and communications manager. They're kind of the three overall team leads of the car. So the whole program is run sort of like a business. So you have a project management aspect where you have scheduling, timing, getting parts. Engineering manager basically is in charge of the sub-teams like mechanical, controls, and electrical, where we actually build the vehicle. And then the communications team outreaches to the region or to sponsors that we could look at, bringing into the vehicle and get the word out what we're doing.
So are the vehicles 100% stock, or do they have internal combustion engines that you take out?
Yeah, when we receive the vehicle, it will be a stock vehicle, and then we'll convert it to our powertrain. And each team is actually doing a different powertrain. And that's kind of where the difference in the competition comes on how each vehicle will score. Because we have to weigh certain options. For example, you can build a vehicle that's super fuel efficient, but it's not going to be fast. So you need to kind of build trade-offs where you have speed and fuel efficiency.
Geez, that's interesting. So it's not mandated that the powertrains are different. They just are, or is it mandated?
Usually they are. Most of the teams will look at different. Everybody thinks differently. So you'll have teams that specialize in diesel, specialize in all-wheel drive, rear-wheel drive. So each team will generally build a different vehicle because of that.
Mm-hmm. So does your team sit down prior to I assume you know what vehicle you're going to get. You sit down before that and you say, okay, guys, what are we going to do? You want a diesel engine? How about a rocket engine? I mean, how do you decide what you're going to put in there?
Well, this entire year one, we actually split up into sub-teams to design different powertrains for the vehicle. So we split up into, was it 4? Yeah, we split up into different 4 teams, and we each proposed different architectures for the car itself. And once we got down to the choosing process for the architectural selection, we narrowed it down to some of our best options so we could propose those to the competition.
And then the competition looks at all our simulation data, CAD data, and whatever we've designed, and they kind of determine based on what vehicle parts we're using, which vehicle to build.
And when you say competition, you're not talking about your competition. You're talking about
the organizers that manage the competition. So okay. Argonne National Laboratories is responsible for overseeing the competition, and then you have headline sponsors like General Motors and the U.S. Department of Energy that assist Argonne, but are the primary sponsors and donate components, money. There's overall 20-plus sponsors involved.
Right. So they kind of overlook this and say, okay, yep, this thing's go ahead, go. Now you guys pulled it into the shop. Last time I was down there, I was really impressed. They had a dynamometer. I haven't seen one of them in years. They had that thing hooked up there. This car was it was hauling on that dyno. That's pretty cool. Yeah,
we do have our chassis dynamometer on campus, and we're looking at adapting that for a rear-wheel drive vehicle. Right now it's set up for a front-wheel drive, but building the Camaro, it's going to be rear-wheel drive. So there's some changes we have to make, but it'll really be moving the Camaro. We're looking at some pretty impressive top speeds of about 130, 140.
Jeez, that is incredible. Okay, so now you've got the car in there, and you jack the thing up and say, okay, boys, let's just take that internal combustion engine out of there, and we're going to put in. What are we going to put in, Tom?
So we're going to put in. We're not exactly entirely sure on all the components yet, but it's looking like we're going to have a vehicle that has a four-cylinder engine and some electric motors, and can go into different modes where the electric motors will drive the car, or all the components can drive the car.
Gee, well, don't give away any trade secrets now.
Gotta be careful.
I think there's somebody from Illinois listening in. Listen, hear them? Yeah, we got some spies out there. So, no, okay. So then, how about the drivetrain? I mean, what are we doing there?
So the drivetrain is going to feature basically a longitudinal four-cylinder engine, which will be disconnected and reconnected from the road using clutches. and then the electric motors will always be attached to the road. And we're also going to have a longitudinal transmission. We're not exactly sure on that part yet, and that will propel the vehicle as well. That'll allow you to shift through gears using paddle shifters.
Okay, like F1, right?
Kind of, yeah, like F1, yeah.
We were talking about F1.
Yeah.
Okay, what's F1, folks? If you're not familiar, that's Formula One. That is the pinnacle of auto racing, correct?
Correct.
Tell us a little snippet. Tell us about Formula One.
Basically, if you look at some of the new Formula One cars, they're all hybrids too now. So Formula One started years ago with some of the supercar sponsors, and now it's still the supercar like Ferrari, Infiniti, McLaren, Mercedes, but now they use smaller engines, 6-cylinder engines with electric motors and electric turbos to recapture energy.
Gee, boy, has ever changed. Hey, folks, we're up against the break. Stay with us. We'll be right back. Hold on to your seat.
Did you ever think the day would come when you could heat and cool your house using solar power only? Well, the future is here. You can now solar air condition and solar heat your home.
SolarFit sets you free.
The Solar Comfort Heating and Air Conditioning System, offered exclusively by SolarFit. Give us a call and let's talk about solar fitting your home. 445-7606. 445-7606.
SolarFit your life and set yourself free with the sun's free energy.
Hello, folks. We're back. Welcome to the SolarFit Renewable Energy Show. I'm here with Jared Norman and Tom Georgia of Embry-Riddle Aeronautical University. We're just talking about Formula One, and my heart's already ramped up. I can remember years ago at Watkins Glen with Mario Andretti and Graham Hill and Jackie Stewart and all these legends of Formula One back in the day where it was relatively dangerous to drive these machines. Now they're still dangerous, but they hug the road. I mean, unbelievable, right?
Oh yeah, suspension is a big part of vehicle design today, especially in like hybrid technology or any vehicle. Like I mentioned earlier, our 2013 Chevy Malibu that we reconstructed, part of that vehicle was to redesign the suspension as well because we added mass to the batteries. So we actually put a racing suspension on the rear wheels, and the vehicle can handle a lot better. Even though the electric motor isn't as strong as a normal gasoline engine, and if you do a straight line acceleration, it gets about 9 seconds. But we autocrossed the vehicle against other cars last year and came in 3rd place until we hit a cone, then 5th place. But
oh, gee. Who was driving? You weren't driving.
General Motors trained professionals that they autocross for their pretty much their professional career.
You should have showed them how to do it. I mean,
yeah.
Come on, really. Well, let's see. Where are we down? We've got the drivetrain in. We've got the engine in. Okay, like that. What kind of a weight are we looking at the car?
So we're looking at approximately 275 kilograms.
Okay, now no one knows what a kilogram here in America, so tell us what that means in weight.
So basically we're adding approximately 7 50-pound battery modules to the rear, and then the main powertrain would be the same. So essentially you're just adding, what's 50 times 70, 350 pounds to the rear of the vehicle.
Okay, great. Okay, what kind of batteries are we talking about, Jared? What are we using?
We're using the lithium pack batteries. It's going to be about 6 packs going into the rear of the vehicle, and students will actually design the entire packaging system and mount it and with everything.
Yeah, so what the competition likes to do is A123 is one of our competition sponsors, and they're providing for us a battery pack that we will basically assemble with modules and the hardware to control the batteries, and then we'll build our own frame and enclosure. And previously our frame and enclosure has been an aluminum frame with a carbon fiber enclosure, and we're going to look at continuing that with some interesting cooling systems. We've done what's called a phase change material, and it's 1/3 the density of aluminum with twice the thermal capacity, which means it will not get nowhere near as warm as an aluminum plate would, and you'd have about 90 minutes before your coolant pump would have to turn on.
Wow, that's a big thing. Now these lithium batteries, lithium ion, are they similar to what Elon Musk is developing?
Yeah, they're pretty similar. He uses lithium ion batteries from used laptops, I believe. They repurpose them for They put them in what's called prismatic cells, and they can basically wire them in series and parallel and really up the voltage.
Wow. Now, are these a series of small batteries put together in kind of a module type thing? Okay.
That's correct.
Right. How many are there in a typical module?
That's hard to say. It varies. I know ours, I believe we have 60 to 70 pouches, but I'm not for certain for sure.
Okay, no.
We don't open those. We get those from the manufacturers.
I don't think you're supposed to open.
No, you're not supposed to.
I'm just curious though, if you had one of the cells go bad in one of the modules, if you can just take it apart and put another one in.
Usually what you'll do is send it to a manufacturer, and they do that. But it's very not recommended that maintenance be done by untrained professionals.
Yeah. So let's talk about hardware and software in-loop simulation.
So part of this year was we had to simulate what our vehicle performance would be. So basically we developed a computer program of the vehicle. And it's not like a video game or something where there's actually graphic. It's actually a lot of numbers and code where basically we simulate how the vehicle would drive. So that's where we get our mile per gallon estimates and our 0 to 60 acceleration, because we actually haven't received our vehicle yet. We'll receive our vehicle next year.
Oh, okay. So you're doing this all in advance. You're designing this in advance. That's pretty interesting.
Yeah, the whole purpose of this year's design and simulation.
Okay, so what happens when it rolls off the trailer in the lot down there in Embry-Riddle? Is there going to be a little excitement or what?
Oh yeah,
absolutely. This car is beautiful.
I was down there when they received the one, I think, from last year. I mean, it was like a bunch of ants. Everyone was jumping all over the place, running around there. And I went, oh my God, this is unbelievable.
Oh yeah.
They had it on the dyno testing, and everybody had their own job. It was fascinating.
Yep, and we're gonna continue that with this vehicle. We're definitely going to be getting a lot of control data. So basically, keeping the vehicle stock for a few weeks, maybe a week or two, and then once we get all the data we've determined we need it, first bolt comes out.
Oh my gosh, that's exciting. And what month do you think the car will arrive?
We're approximating between November and December, but we're not positive.
Okay. Well, that'll come around real quick.
Yeah.
What about control systems? How will they be controlled?
So control systems, we're looking at using a microprocessor provided by a competition sponsor where we will basically input our code that controls the vehicle. So the hardware in the loop allows us to simulate how the vehicle would act, all the components would communicate with each other. And what we'll do there is we'll develop a control strategy where, the engine turns on at this parameter or the electric motor turns on at this parameter, and then we can take that and test it in hardware in the loop without actually turning an engine on or turning an electric motor on. Once we do that, we incorporate it into the actual vehicle, and we can see if everything is acting the way it's supposed to. And usually there's some slight adjustments, a few numbers have to be changed, but generally we can get the vehicle running from that code.
So will this operate similar to other hybrids where the electric motors will start out initially, and then when they need a boost, the other engine will kick in? Is that what'll...
That's what we're looking at for sports mode. In sports mode, basically, the engine will be running and the electric motors will assist. And in economy mode, maybe the engine is loaded by the motors or the motors are just driving the vehicle. So it really depends on the modes of operation. A lot of that's based on our simulation data, which still isn't finalized yet, so I don't want to get anybody's hopes up.
Okay. So what do you think? Have you been watching the solar impulse going around the world? Have you been keeping your eye on that?
No, I actually haven't.
In aviation, and Embry-Riddle, this is like the coolest thing in the world. It's a plane to Swiss. I want to call them adventurers. One's actually a psychiatrist, and the other one's kind of an adventurer. And they're going around the world on the first ever solar-powered flight around the world. And right now they're in China. They'll be getting back to the United States sometime in May. But when I'm thinking of electric motors and I'm thinking about batteries, I'm thinking about these solar cells powering this plane up in the air without any power but the sun's free energy. What do you think?
It sounds very interesting. I believe the technology, though, is strong enough that it shouldn't really make anybody worry or it shouldn't be fearful.
Well, they're doing a great job. They came across the United States, last year, and we're looking forward to interviewing when they come back into May, so that should be fun. Out in front where you guys are, did you notice the solar modules by any chance? You know, your little, you see your little observatory there?
Oh, yes, yeah, we did notice those.
Well, the students have just put in some solar modules, and they're going to operate a solar air conditioning and heating system for the observatory.
Wonderful.
Yeah, just so in case you didn't know what it was, it's pretty neat.
Absolutely.
Yeah, absolutely. So what's the next step? What are you guys working on next? You're getting ready to graduate, I understand.
Yeah, getting ready to graduate, and the next step is finding work and making sure you move on to the next adventure.
Well, I would imagine people like General Motors and all these different industries are looking for guys like you, I imagine.
Yeah, I mean, that's the plan, just to really appeal to their interest and hopefully get to the next step.
Well, what do you think of Embry-Riddle as a university?
Embry-Riddle as a university, it was an amazing experience. The 4 years I was there, of course, I had a lot of fun playing athletics for them. It opened a lot of doors, and I met a lot of very awesome friends and very interesting people. And on the engineering side of things, there's so much intelligence and so many people to look up to and to learn from. And it was just a really humbling experience to see a university teach you how industry actually is. And it was really fun to be a part of that.
Who were some of your professors?
Some of my Dr. Courier is actually our faculty advisor for EcoCAR, and he's a brilliant man. He's a good guy, very intelligent. He helps us through any kind of problem or speed bump we might run into, but he's a great professor in the means that he allows us to try to overcome our challenges individually before he truly steps in, which is a great learning experience.
Well, you've got Dr. Reinholz out there,
yes.
And you've got Dr. Compier. You've got some really, really awesome people that what really appeals, to me as kind of, an old Embry-Riddle guy back in 70 and 71 to walk in there and see students in there any time at night having free reign of their laboratory, if you will. If they have a concept or something that comes to their head, they just walk right in and start working. I think that is awesome.
24-hour access anytime we need to fix something, study, or get back to work, we can just go back to school.
Yeah, remember the stories of Microsoft and how that started and how the whole work ethic just completely turned itself on its ear, where people could pretty much do whatever they want, dress however they want, eat whatever they want, work whenever they want, and look what's happened.
Yes.
Yeah. You don't really need a lot of direction if you're self-disciplined and have your own guidance system, do you, Tom?
No, you don't. I mean, there are the tools, and it's nice to have access to them, which is what Embry-Riddle provides. A great mind at Embry-Riddle or anywhere, is really needed tools or software or even a machine to build a prototype or work further. And Embry-Riddle offers that great opportunity. Like, best example would be that chassis dynamometer, where we can actually test our vehicle that we build and our ideas to see if our fuel economy numbers or our emission data is accurate.
Right. What about aerodynamics? It plays such a strong part in racing and stuff like that. Do you see yourself down the road? Do you see Embry-Riddle having a wind tunnel?
I mean, anything's possible. I can't say for certain, but it would be nice. It would be really cool to maybe put an EcoCAR, a future EcoCAR, in a wind tunnel and get some actual data, because we're one of the only teams that do aerodynamic modifications to our vehicle. So a lot of the vehicles will show up to competition pretty stock, and then ours will roll in with some louvers, spoilers, side skirts, and people turn some heads and get some attention. That's for sure.
Well, if you're looking at top speed or handling or anything like that, aerodynamics is so important. I mean, you can't give any secrets away on that, because that's going to be the killer right there.
Oh yeah, it's definitely a big improvement, because your number one force acting on a vehicle once you get moving is your aero force. And so to overcome a lot of that drag would increase fuel efficiency for certain. For
sure. What about consumption, energy consumption? You notice these gas prices, they go up, they get down. You notice we have no control over them. Right now they're kind of moderate. They've really kind of conditioned us to think that we're getting a good deal at $2.50 a gallon, where 5 years ago $2 a gallon would have been unheard of, right? So where do you see that going?
Hard to say. I know with more of these fuel-efficient vehicles, probably the prices will start to increase just because the demand for gas won't be as high. But electric vehicles, charging off the wall, you save a lot of money. You don't, I believe one of our calculations here in Daytona, the estimate for like mile per gallon was 34 cents.
Wow.
For like a gallon of fuel equivalents.
Yeah. Well, it's coming. I mean, if you go to California right now, you can drive the whole state just in your plug-in car. And it's not here yet, but it will. It's coming here. It's exciting technology.
Oh, yeah, for sure.
Yeah. We like the idea of solar charging stations, right, where you have a carport. And we're looking at some potential now for Embry-Riddle having a solar carport charging station where you can bring in your cars and just plug them in. And wouldn't that be an awesome display out there?
Oh, that'd be wonderful, yeah.
Jeez.
Definitely. It's off-the-grid technology, and it's what we need for electric cars because electric cars can't be dependent on the grid technology because the grid could go down. And if you have a solar panel station that's self-sustaining, you just pull right up, charge, and go.
Yeah, for sure. Yeah, we talk about that sometime on the show because we're, big proponents of clean energy, as you guys are, and, the potential of something like the power going down and not having the access to fuel could just drive the country in 3 or 4 days into desperation because you wouldn't be able to get fuel, you wouldn't be able to get food to the stores and things like that. So it's really we're going in the right direction. I think you guys are leading the way, man. We really appreciate it.
Thank you. Yeah, we want to be the leaders. So.
Well, Embry-Riddle is known for that. I'll tell you, it's awesome. I can't open a paper any day that I don't see that Embry-Riddle first and foremost won another competition. So it's got to be a great feeling.
Oh, it is.
Well, guys, we're almost out of time. I want to thank you both for coming in. It's just been an awesome experience for us, and I hope the listeners out there, will really, think about coming to Embry-Riddle. If you give us a call, if you give our office a call, we'll help set up a guided tour for the engineering department, and you would be awestruck at what's happened over the last few years. And obviously we'd love to have your support out there at the school, so feel free to give the folks at SolarFit a call or just call out to Embry-Riddle and say, hey, how can I get involved? And if you've got kids coming up right now and you want to go to a high-performance university, Embry-Riddle is the one to go.
For certain. We'll definitely show people around. We love to show people the EcoCAR lab, the robotics labs, and every other lab we have. So.
Awesome, guys. Well, thank you so much. Have a wonderful weekend, man. And we'll see you back out to school soon.
All right. Thank you.
Thanks, man. All right. Well, that completes our show today, folks. I hope you enjoyed as much as I did talking with Jared and Tom. They're awesome dudes from Embry-Riddle, and they've got a bright future ahead of them. And thank goodness that they're leading the way because, clean energy is what we need for our future. So thanks for tuning in, folks. Have a wonderful weekend, and we'll talk to you next week.